Hello students, today you are going to understand about the Schrödinger's wave equation. Schrödinger wave equation describes completely the physical system with respect to space variable r and time. These wave equations also describes completely the behavior of matter wave. As we all know about the significance of matter wave is the wave associated with a particle or particle associated with a wave. And according to de Broglie, the wavelength of the matter wave can be calculated as lambda is equal to h by p or lambda is h by mv. Schrödinger considered the same idea of de Broglie waves and he set up a differential wave equation and applied to the various atomic problems. These wave equations are considered as the heart of quantum mechanics. The solution of these wave equations are more consistent with the wave aspect, particle aspect and the uncertainty principle. Hence, these wave equations can be applied to solve various quantum mechanical problems. Now let us understand one of the differential wave equation from Schrödinger idea, that is Schrödinger's one-dimensional time-independent wave equation. Now let us discuss one-dimensional Schrödinger's time-independent wave equation. If the wave equation takes care of only the space variable of the wave function, then it is called Schrödinger's time-independent wave equation. So in this context, we will understand how to derive a differential wave equation for time-independent case. Let us consider a material particle of mass m moving with velocity v. And this particle is associated with wave. Hence, as per de Broglie theory, one can write the wavelength of this wave associated with a particle can be written as lambda is h by mv. As we know that the Schrödinger wave equation is used to describe completely the behavior of a matter wave, Schrödinger used the de Broglie idea and he had written the classical differential wave equation for a matter wave. Accordingly, we can write the one-dimensional classical differential wave equation is given by del square psi by del t square is equal to v square del square psi by del x square. Here you can understand the psi refers to the wave function and v refers to the wave velocity. So now, since it is for time independent case, we need to extend. So in the given differential equation, we have to eliminate the time variable actually. So for this, first we need to write the solution for this differential wave equation. Solution of the above differential equation is given by psi of x comma t is equal to psi naught of x into e power minus I omega t. So this is the solution for the above differential equation which can be called as equation 3. Now let us differentiate this solution with respect to time in order to eliminate a factor in the given differential wave equation del square psi by del t square. Differentiate equation 3 with respect to t. We get del psi by del t is psi naught of x e power minus I omega t into minus I omega. So again we are differentiating this solution with respect to t. Again differentiating with respect to t, we get del square psi by del t square is equal to psi naught of x e power minus I omega t into minus I omega whole square. So now let us solve the right hand side of this particular equation, then we will try to get the value of del square psi by del t square first. Del square psi by del t square can be written as psi naught of x e power minus I omega t. We had actually minus I omega square, which can be written as I square omega square. As we know that I square is minus 1, we get the value as minus omega square, which I am going to substitute here, minus omega square. Now we get the value of this psi naught of x e power minus I omega t can be considered as psi itself. So we write here the value as minus omega square of psi, which can be called as equation 4. Now substitute the value of equation 4 in equation 2, substituting the value of del square psi by del t square in equation 2, we get minus omega square psi is equal to v square del square psi by del x square. Now let us send this v square to the other side and we can write the equation first of the form del square psi by del x square is minus omega square by v square of psi, which can also be written as del square psi by del x square is equal to, del square psi by del x square plus omega square by v square of psi is equal to 0, which can be written as equation 5. Now further let us understand the value of omega by v. We know that omega can be written as the angular frequency in terms of linear frequency. Omega is 2 pi nu, and nu, that frequency of the wave, can be written as velocity, which is nothing but v by lambda. Now the value of omega by v can be written as 2 pi by lambda. In turn, omega by v can be written as lambda is h by mv. We can substitute here and we can write actually omega by v as 2 pi by h m into v. So we can substitute the value of omega by v in the previous equation, that is del square psi by del x square plus omega by v is this much. So omega square by v square we want, so which can be written directly as 4 pi square by h square m square v square of psi equal to 0. You can call this as equation 7. And here at this point, in order to figure out what is the value of this m square v square, let us understand the total energy of the particle. The total energy of the particle can be considered as the sum of potential energy and the kinetic energy. The total energy, let me write as capital E, net energy of the particle, which is the sum of the potential energy capital V plus the kinetic energy can be written as of mv square. Now with the help of this kinetic energy, we can figure out the value of m square v square. We can write now of mv square as equal to total energy of the particle minus the potential energy of the particle. Now at this point, let us multiply and divide by a factor called m in order to figure out the value of m square v square. So we can write of, which is m by m, mv square can be written as equal to E minus V. So this implies the value of m square v square can be estimated as 2m E minus V. Now let us substitute the value of this m square v square in the previous equation. Our previous equation is del square psi by del x square plus, it was like 4 pi square. Our previous equation is del square psi by del x square 4 pi square by h square m square v square. Instead of writing m square v square, now let us write that value as 2m E minus V of psi is equal to 0. And now we can complete this derivation by, now we can complete this derivation by simplifying this particular second term of the equation, now which can be written as 8 pi square m by h square E minus V of psi is equal to 0, and this differential equation represents one-dimensional Schrödinger time independent wave equation. Thank you.